So we can use pattern blocks to think about an area model for fractions. So looking at the pattern blocks, if we think about this yellow hexagon as equaling one whole, that means that the space that it's taking up is creating the whole. So we can think about this yellow hexagon equaling one whole. The space that is taking up equals 1, so that if I have one yellow hexagon, that equals 1. 2 yellow hexagons would equal 2 wholes. 3 yellow hexagons would equal 3 wholes. All right, so now let's talk about the other pattern blocks that we can use to think about fractions. We're going to look at this red trapezoid and think about how much of the area or the space does this red trapezoid take up. So I can put it over that space and see how much it takes up to determine which fraction of the whole it would be. I might also grab another one and create the whole with this pattern block. So I can see that it takes 2 red trapezoids to make a yellow hexagon. Therefore, 1 red trapezoid would equal 1/2 of my whole, or 1 out of 2 pieces that would make up my whole. Next, we can also think about the blue rhombus. Again, I want to know the value of the blue rhombus based on the yellow hexagon equaling one whole. So I can overlap my blue rhombus with the whole. And see how many pieces it takes to make one whole. I see that it takes 3 pieces. Therefore, I can talk about the blue rhombus as being 1/3 or 1 out of 3 pieces that make up the whole. And then finally, I want to talk about the green triangle. Okay, I need to know how many green triangles it takes to make one whole, so I can fill up the one whole with my green triangles and see how many of these it would take to make the whole. And the last one. Okay, so I can see that it takes 6 green triangles to make one whole. Therefore, 1 triangle would equal 1/6 of the whole hexagon. Okay, so this is if the yellow hexagon equals one whole, but that does not have to be the situation. It does not have to be that the yellow hexagon equals 1. It could be any block. Any of these blocks can equal one whole. That's the nice thing about pattern blocks. They do not have numbers on them, but they do have a relationship where it's always going to take 2 red trapezoids to make 1 yellow hexagon. It's always going to take 3 blue rhombuses to make the yellow hexagon. And it's always going to take 6 green triangles to make the yellow hexagon. So there's a relationship, and that relationship is constant, but as we change what one whole looks like, the area, the size of one whole, then the value that we can give to the blocks also changes. So, for example, instead of the yellow hexagon equaling one whole, let's think about the red trapezoid equaling one whole. Okay, so now my whole has changed in size. It looks different, but I can still think about the value of the other 3 blocks. For example, the yellow hexagon. Okay, if the red trapezoid equals 1 whole, now the yellow hexagon is going to have a different value. This is 1 whole. Well, 2 red trapezoids make up the yellow hexagon. That means that the yellow hexagon is going to be worth 1 whole, 2 wholes. Okay, so this time, because my whole has changed in size, the value of this block changes as well. The relationship stays the same. It still takes 2 red trapezoids to make a yellow hexagon, but the value of those blocks have changed. Okay, let's look at the green triangle. Okay, the red trapezoid equals 1 whole, so once again, I want to know how many green triangles can or do take up that space of 1 whole. Okay. It takes 3 green triangles to make 1 whole. Therefore, 1 green triangle is going to equal 1/3 of the whole. And then a little bit trickier will be the blue rhombus. Okay, again, we want to see how many blue rhombuses it takes to make 1 whole. So I'm going to fit them in here. And I notice that I can fit 1 blue rhombus in here, but I cannot fit a second one. Okay, and so now I need to determine how much of that blue rhombus is filling up the hole or the red trapezoid. One way to do this might be to think about how many triangles are fitting into the blue, rhombus. Okay, 2 green triangles fit into the blue rhombus, and so that would be the same as saying 2 of my 1/3. 1/3 fits in, and then 2/3 fits in. So the blue rhombus would equal 2/3 of my red trapezoid.